everyone. Our topic for today is all about basic integration formulas. Here are the integral formulae. Integrals. Number 1, the integral of du equals u plus c. Number 2, the integral of e du is equal to a the integral of du. Number 3, the integral of du plus dv equals the integral of du plus the integral of dv. Number 4, the integral of u to the n du equals u to the n plus 1 over n plus 1 plus c. N is not equal to -1. Number 5, the integral of du over u equals ln the absolute of u plus c. Number 6, the integral of e to the u du equals e to the u plus c. Number 7, the integral of eu du equals eu over ln e plus c. Number 8, the integral of cosine u du equals sine u plus c. Number 9, the integral of sine u du equals negative cosine u plus c. Number 10, the integral of tangent u du equals ln the absolute of secant u plus c. Number 11, the integral of cot u du equals ln the absolute of sine u plus c. Number 12, the integral of secant squared u du equals tan u plus c. Number 13, the integral of csc squared u du equals negative cot u plus c. Number 14, the integral of secant u tangent u du equals secant u plus c. Number 15, the integral of cosecant u cotangent u du equals negative cosecant u plus c. Number 16, the integral of du over square root of 1 minus u squared equals sine raised to -1 plus c or negative sine plus c. So this topic, we need to know the differentials, the different properties of differential. So as we recall the differentials property, so we need to read this to recall all differentials. Okay, number 1, du equals du over dx dx. Number 2, d times eu equals e du. Number 3, d times u plus v equals du plus dv. Number 4, d times u raised to n equals nu n raised to n minus 1 du. Number 5, d times ln u equals du over u. Number 6, d times e to the u equals eu du. Number 7, d eu equals eu ln e du. Number 8, d times sine u equals cosine u du. Number 9, d cosine u equals negative sine u du. Number 10, d ln the absolute of secant u equals tangent u. Number 11, d ln the absolute of u sine u equals cotangent u. Number 12, d tangent u equals secant squared u du. Number 13, d cotangent u equals negative cosecant squared u du. Number 14, d secant u equals secant u tangent u du. 15, d cosecant u equals negative cosecant u times cotangent u du. 16, d sine raised to -1 u equals du over square root of 1 minus u squared. Number 17, d tangent raised to -1 u equals du over 1 plus u squared. Number 18, d secant raised to -1 u equals du over the absolute of u squared negative 1. So next, so we know the integration, we know the integral formulae, so we have an examples na evaluate. Number 1, the integral of 16x over 8x squared plus 2 dx. So we're here in the solution. So the solution of the integral of 16x over 8x squared plus 2 dx. So first, we must separate this. So we have like this, the integral of 16x times 1 over 8x squared plus 2 dx. So after that, we get the u. So our u is 8x squared plus 2. So we get the derivative of 8x squared plus 2. We have du over dx equals 16x. Then, we back to our integral. So the integral of 1 over 8x squared plus 16x dx equals the integral of 1 over u. So because 8x squared plus 2 is equal to u, so we put u here times du, and also the 16x dx is equal to du, so we put du here. So we have the integral of du over u. So the result of the integral of du over u, we have ln the absolute value of u, plus c. So we all know that u is equal to 8x squared plus 2, so we must substitute. So the final answer is ln times ln the absolute value of 8x squared plus 2 plus c. So this is the final answer of example number 1. Example number 2. The integral of x times sine x dx. So this problem, we need to use the integration by parts. So the integration by parts formula is equal to the integral of u dv equals uv minus the integral of v du. U here is choose something that becomes simpler when differentiated, and dv here is choose something whose integral is simple. So solution, ru is x, and the derivative of x is du equals dx, and the dv here are sine x dx. So the integration of sine x dx is equal to negative v equals negative cosine x. So next, so by using integral by parts formula, we have the integral x sine x dx equals uv minus the integral of b du. So by substitution, u is x times negative cosine x because v is equal to negative cosine x minus the integral of negative cosine x dx because du is dx and negative cosine x is v. So simplify. So we need to simplify. So the result is negative x cosine x plus the integral of cosine x dx. So the final is we need to integrate this part. So the result is negative x cosine x plus sine x plus c. So this is the final answer of example number 2. Negative x cosine x plus sine x plus c. So it's your turn to solve. Activities. Evaluate. Number 1. The integral of 6x times square root of 3x squared plus 5 dx. Number 2. The integral of x cubed plus 2x raised to negative 2 plus x raised to negative 5 dx. Number 3. The integral of a to the x second squared a to the x dx. Number 4. The integral of dx over 2x minus 7 squared. Number 5. The integral of x squared times sine x dx. So the activity number 5, we need to use the integration by parts formula. The integral of u dv equals uv minus the integral v times du. So that is your activities. Thank you.